Sometimes you want your steam to be hotter, drier, and more energetic than regular steam. In that case, superheated steam is what you need. But what exactly are the defining characteristics of superheated steam? And when do customers need it? We'll go into that in this Steam Nugget. Superheated steam is steam that has been heated beyond its boiling point. As a result, it's completely dry. This graph shows the changes in temperature and phase that occur when you keep adding energy to water. At standard atmospheric pressure, that's 0 bar gauge, water boils at 100 degrees Celsius. And when it does, it turns into vapor or steam. This steam is called wet steam or unsaturated steam because it contains water droplets. To make superheated steam, you need to keep adding thermal energy until all the water molecules have turned into steam. At that tipping point, the wet steam becomes dry steam or saturated steam. When you add even more thermal energy, the temperature will rise further, and you will have superheated steam. At atmospheric pressure, superheated steam has a temperature that is above 100 degrees Celsius. Let's have a closer look at what we mean when we say steam is dry. Steam is called dry when it contains no more water droplets. In that case, we also say that the steam dryness fraction equals 1. And when the steam dryness fraction is 1, the steam quality is considered to be 100%. Steam that is produced by boilers usually still contain a small percentage of water. In that case, the steam dryness fraction is lower than 1, and the steam quality is below 100%. There are several ways to increase the steam dryness fraction, and thus the steam quality. The first option is to reduce the pressure. When you bring steam to a lower pressure, its boiling temperature is also lowered. The steam has more energy than it needs to stay at a boiling point, and can use its extra energy to help evaporate the remaining water droplets, making the steam drier. The second option is superheating the steam. As explained before, when you keep adding thermal energy to steam, it will eventually become completely dry. The third way is by mechanically capturing the water droplets. This can be done with demisters that are directly inside the boiler shell at the main steam outlet. Or you can position steam and water separators in well-chosen spots on the steam line. In summary, let's list both the advantages and disadvantages of superheated steam. On the positive side, superheated steam is of 100% quality because it is dry, it has a higher energy content, and it requires a network with less steam traps. It can travel at up to twice the speed of saturated steam, which in turn means that piping with a smaller diameter is sufficient. But there are disadvantages as well. Superheated steam requires more energy to produce, and you also need more equipment to do so, a superheater and a desuperheater. The network will need piping of a higher category because of the steam's higher temperature. Finally, superheated steam has a low heat transfer, and it requires desuperheating to release the latent heat. We now know what superheated steam is, but in what exact circumstances do customers need it? A first reason is simply because the process requires superheated steam. This can be the case in applications such as sterilization, heating, drying, etc. Secondly, superheated steam can be needed to power equipment such as turbines, engines, and pumps. And finally, superheated steam is important when you need high-quality steam in distant locations from the boiler house. When your steam network is extensive, superheated steam can provide the solution. Also, when the network was specifically designed for superheated steam, with less steam traps and smaller diameter lines, saturated steam is not an option. Remember, superheated steam is steam that has been heated beyond its boiling point. It is drier, hotter, and more energetic than regular steam, making it useful for various industrial applications.